So we're continuing to conduct sensitivity analysis using decision trees, how to make decisions when there is uncertainty. So in this particular example, we looked at, we have a new product. Should we invest in R&D? And so after that, should we then market it? And once we market it and we sell it, it might be a positive economy, it might be a negative economy. So notice some parts of the decision tree we decide and some parts are decided for us. What we need for our decision tree is the probability of the various outcomes and the return that we get from them. So for example, 30% likelihood we'll invest in research and development. That's going to cost us, so a negative $10,000. If we decide to invest in marketing, 60% chance we do that after R&D, it's going to cost us $5,000. If there's a positive or negative economy, 40% chance of a good one, 60% chance of a bad one. And here we have our price of $35 times the quantity that we should be able to sell. That quantity is changing here with the good and bad economy. Well, what if the price isn't $35? So what if the market's determining that our product is worth a different amount, not 35? We can do a sensitivity analysis to figure out how much our decision is based on that $35. So to do this in Python, just a reminder, we are in drstephpowers.github.io/BIA. We're doing optimization here under prescriptive analytics. So in our code, what we have done is that we have created a function that lines out the different paths in our decision tree and has it come up with the value. As it goes through the path, it's going to add money or cost us money. And so we have 4 paths here tied to our tree here. We have, for example, you just terminate immediately, you invest, then terminate, you invest, do the marketing, and then it's a bad economy. You invest, market, and it's a good economy. So we got 4 different options here for routes, and we show that here with our function. And we find the probability of each of those routes by multiplying the probability for all the events or activities that are happening on that route. So here it's the probability of A1 times the probability of A3 times the probability of A5. What we're getting it to do is then come up with the expected monetary value by multiplying the cost of each path times the probability of those paths and then adding them all together. All right, so we are doing some sensitivity analysis here, and we are looking at what if we change the price. So to set this up, what we do is we're going to create an empty list called EMV_com. You can call it whatever you want, but it's the expected monetary value, and then this is our complete table. So that's why I have that. And we're going to do a sensitivity analysis here where we change the price. So initially we had looked at a price of $35. What if the price is much lower than that? So what if things are much worse than we anticipate? Here, let's assume that the quantities are in a good economy 3,500, in a bad economy 1,400. In our previous scenario, we changed the quantities and held the price constant. Here we're changing the price. You could actually do them both and just create a loop inside of a loop. So you see this loop here that we're about to create says for X in P, and it goes through P. But you could also have outside of that for Y in your sensitivity, and then you run through all the different prices for one set of quantity, and then you run through all the prices again for another set of quantity. Your loop takes longer now to do, and your output is going to get even bigger. But you can totally run all those scenarios if you want to see all combinations of prices and quantities. But for this moment, let's just do the price. Okay, so we're going to look at a range of prices from 5 to 35, and we'll leave the quantities as 3,500 and 1,400. So let's create a loop here, and the way we're going to do this is we're going to say for X or whatever placeholder you want in, and then this is where we're referencing P here, our list we made of prices. We're going to create the actual table inside of the loop, and that way we can then have those index references for our function. So here we have our activity equals A1, A2, A3, A4, A5, A6. The probability of these: 30% we do R&D, 70% we quit the project, 60% we do marketing, 40% we quit the project, 40% the economy is good, 60% the economy is bad, and then the cost here of R&D, quitting, marketing, quitting, and then the money we make in terms of selling our revenue are coming in from the good economy and the bad economy. So notice here we have quantity high times X, and that's because the X is going to be the price. And so the revenue comes from price times quantity. We're going to create a table, a data frame using pandas with activity, probability, and value as the columns. And then we're moving the activity over to index. The reason we're doing this is that we had created a function. Why are we getting stuck here? We had created this function here that looks at the location on the table to pull the values and the probabilities. So if you had created this function in a different format to pull information, you could skip creating that data frame. I know it's not the fastest way to code in Python to put everything in tables. Python is much more built for lists and not tables itself, but I have trouble. I'm a table person. I need to see it as a table. And so creating the functions from a table helps me. If these databases, if this information was a lot bigger and more cumbersome, then we would try to find more efficient ways to do this. But I need to see the table so that I can see what's going on. All right, so we're going to then move that activity over as the index replacement and then have it do that function and output the different paths and the probability of those paths. So again, this part right here of our loop and the corresponding function are highly dependent on your decision tree and how it looks. Okay. All right. So we've put in the assumptions. Let's run the loop. And then, because again, I think in tables, let's convert that output, which is one giant list, into a data frame using pandas, and then call the table. And so when we look at this, notice that if the price falls down to $5, the expected monetary value here is a negative 1884. So this is the first time we've seen in our analysis where it is not going to be financially viable for us to do this project if the price falls below 5. And so then we start to look at, well, what is the probability that that would happen? Is it high? Are we willing to deal with that? Is this amount of loss so substantial that that would steer us away from this? Or given the low probability, given the loss is only $2,000, what is that we're willing to risk it? And so we can look at the other end, because the other end, of course, is that if the price is much higher, you can see how much you would be making instead. Okay, so we're using this information and the sensitivity analysis to help us make decisions for our organization. If we want to plot what is happening, we are going to need to import matplotlib.pyplot as PLT. And what we'll do here is we will have a bar graph. So we're going to do dot plot. We'll take our table and do dot plot. The kind equals bar. On the x-axis, we're putting our different prices. And on our vertical axis, we're putting our expected monetary value. X label price, Y label EMV, and we'll run that. And so then you can see the return on the project depending on what happens with the price. So you can see for this range of prices, we're making $2,000 or more. Once we start falling below $15, the money we're making is negligible or negative. So that will impact then the decision that we make as an organization, whether or not we should move forward on this new product.